Yeah. Good morning, students. Today we will discuss about a problem on stepped bar. In the last class, I had explained about different types of bars: prismatic bar, circular tapering bar, and rectangular tapering rod. Today we will take one problem on stepped bar. A stepped bar is a bar in which case the diameters or the cross-sectional areas of different segments of the bar will change. So it is not uniform. You can see here from here to here. If I take this as AB, length is 1200 mm. Cross-sectional area, maybe it may be circular or rectangular, we don't know. Anyway, we are interested in the area only. 625 mm square is the cross-sectional area of this. If you cut like this, the area is 625 mm square. For this portion of the bar, length is 600 mm and area is 2500 mm square. And for this portion, length is 900 mm and area is 1250 mm square. Now, the value of Young's modulus, of course, it is same because it is made up of same material. So it is given as E is equal to 2.1 10 power 5 Newton per mm square. That is steel, value of steel. And this stepped bar is subjected to 4 forces. You can see here, axial forces. So all these 4 forces are acting along the axis of the bar. So P1 is a tensile force acting at this end. Its value is 45 kN. P2 is also a tensile force for this, which whose value is not known here. P3, of course, it is 450 kN acting in this direction. P4 is also a tensile force acting away from this third portion, 130 kN. In this case, P2 is not known, but anyway we can find out P2 by applying the equilibrium equation later. So the question here is, he has given the areas of these 3 segments, lengths of these 3 segments, and forces acting on these 3 segments. So we have to find out the total elongation of the bar or contraction of the bar, delta L. Delta L for the entire stepped bar we have to find out. As I already told, that delta L consists of delta L1, delta L2 and delta L3. So delta L1 is the deformation in this bar, delta L2 is the deformation in this portion, delta L3 is the deformation in this portion. Now in this problem, first of all we have to find out this P2 value. It is not given here. That P2 value we have to find out. Then total elongation of the bar we have to find out. Then he has also asked what are the stresses in these 3 segments. Because stress directly depends on the force acting on the bar and also it is inversely proportional to the area. We know that force, whatever resistance force developed in the segment divided by the cross-sectional area gives the stress value in that particular segment. So here, if I take the areas as A1, A2, A3, stress in this portion will be P1 divided by A1. Stress in the second portion will be whatever force is acting in this, that we have to find out, resultant force acting on this segment divided by the A2 value, area of this segment. Then stress sigma 3 is given by the force acting on this divided by area of this portion. So that is how we have to calculate the stress values. Once again, stress can be tensile or compression. If elongation takes place, if the segment is subjected to tensile force, then it is tensile stress. If contraction takes place, that is if the segment is subjected to contraction, then compressive stress will develop. That's all. So tension force leads to tensile stress, compressive force leads to compressive stress. That we will decide later. Now, first thing we have to find out is P2 value. P2 value is not known. So here, if you write down these forces, whatever forces are given like this, P1 is acting towards left, P2 is acting towards right, P3 is acting towards left, P4 is acting towards right. So according to the equilibrium equation, so we are using equilibrium equation, sigma fx is equal to 0 here, treating towards right positive, towards left negative, you are going to get this equation. So you can see here P2 plus P4 they are acting towards right. So P2 plus P4 should be equal to P1 plus P3. These two are acting towards left. So sum of the forces acting towards right should be equal to sum of the forces acting towards left. If you use this equation, simple equation, you get P2 value as 365. So 365 kN is the value of P2. So that is the first part. Then we have to find out the deformations in each bar and the total deformation. So for that, we require to have, we have to consider the equilibrium of each segment separately. So there are three segments here. We have to consider the equilibrium of each segment separately. Then we should come to know about what are the forces acting on those each segments. Then only we can use the formula, respective formula. So first let us see how we have to deal with the equilibrium of each segment separately. So what I have done here is I have taken the first segment and the last segment. So first segment and last segment, in the first segment he has given a tensile force of 45 kN, that is P1, I have taken it directly. And last segment he has given a tensile force of 130 kN, directly he has given in the problem. So I have considered it. So first step, we have to consider whatever end forces are given. You consider the end segments and whatever end forces, that is tensile or compressive, whatever he has given, you consider that. Then what you have to do is you write down the middle portion, middle segment. So now we know that the first portion is subjected to a tensile force of 45 kN. Third portion is subjected to a tensile force of 130 kN. But we don't know what is the force acting on the second segment. So acting on the second segment. For that, what we have to do is, now you consider this first portion. It is subjected to tensile force at this end. Therefore, for equilibrium, we should have a 45 kN at this end also. Then only the bar will be in equilibrium. Now, in addition to that, what he has given here is P2 he has given. So what is the value of P2 here? I am considering the junction. Junction is B here. So if you consider the junction B, he has given a force P2 here. That also we have to take. It is like this, towards right. So that is 365 as given. Now what we have to do is, I have introduced 145 kN here. So to nullify the effect of this, we have to introduce another 45 in the opposite direction. So this is given. This is given. This is given. This is introduced one. This is introduced. So to nullify the effect of this, I have to take another 45 in the opposite direction. Now, if you observe these two forces, 365 is acting towards right, 45 is acting towards left. If you combine these two, the net effect will be 320, which is acting in this direction. See, 365 in this direction, 45 in this direction. Take the difference because they are acting in the opposite direction. 320 is the force acting in this direction. Similarly, you consider this C, junction C you consider. If you consider junction C, 130 kN is acting at this end D for this third segment. To keep that third segment in equilibrium, we have to introduce another 130 kN in the opposite direction. See here. So this is under tension. Now to nullify the effect of this, because it is introduced one. So this is given, but this is introduced. I have to nullify the effect of this. So I have to take another 130 in the opposite direction, like this. Now this 450 is given in the problem. 450 is given in the problem. So that also you have to write down. Now the thing is, now this is in equilibrium, 130 over. Now we have to take these two now. So these two means 450 acting in this direction, 130 acting in this direction. If you subtract, because they are acting in opposite direction, the net effect will be 450 minus 130, 320 acting in this direction. Now that means segment 2 if you write separately, so 320 is acting in this direction, 320 is acting in this direction. That means finally what we can say is this is subjected to a compressive force of 320 kN. So one check is whatever force you are going to get here at this end, at the end B, same force you have to get at the end C. Then only your answer is correct. So we have to check that. So that can be judged like this. Now we have got all the three. So segment 1 is subjected to tensile force of 45 kN. T I have written here. Segment 3 is subjected to tensile force of 130 kN. Segment 2 is subjected to compressive force of 320 kN. So now we have come to know what are the forces we have to consider for finding stresses and all. Now what we have to do is, we know that the first one is subjected to delta L1. Second one is having a deformation of delta L2. Third one is having a deformation of delta L3. Now your total deformation will be delta 1. Delta L is total deformation of the entire stepped bar. It is delta L1 because this is positive. So delta L1 is positive because it is subjected to tensile force. Delta L2 becomes negative because it is subjected to compressive force, negative. Delta L3 once again it is tension force, it is positive. That's why I have written like this. Delta L1 minus delta L2 plus delta L3. First segment is subjected to elongation, second one is subjected to contraction, third one is subjected to elongation. Now, since they are all prismatic bars, so stepped bar is nothing but combination of prismatic bars. So from here to here, cross sectional area is there. The formula to find a deformation in a prismatic bar is PL by AE that we have discussed in last class. PL by AE, since I am taking for the first one, it is P1 L1 by A1 into E. E is common for all the three because all the three segments are made up of same material, steel. Minus I have to take here because it is contraction. P2 L2 divided by A2 into E. P2 is the force acting on the second one. So please note that, don't confuse that P1, P2 with this given values. Here, this is P1. This value is P1 now. This value is P2. This value is P3. Okay? Now I am considered separately. So this is given in the problem. Instead of giving 45 here, he has given it as P1, P2, P3, P4. But after taking the equilibrium condition of all the three segments, we have got individually the values of P1 and P2 and P3. So these values you have to put here. So this is minus because it is contraction. Then once again third segment is subjected to tension force, therefore plus elongation. P3 L3 by A3 into E. Now you have all the values. So here 1 by E I had taken outside because E is constant. 1 by E is given as 2.1 into 10 power 5 Newton per mm square. As already told, forces should be substituted in newtons, length in millimeters, area in millimeter square, Young's modulus in Newton per millimeter square. So these units you have to stick on. So once you use those units, P1 becomes now, this is P1, 45 into 10 cube, that is kilonewton converted to Newton. So 45 into 10 cube newtons into length of that first bar is 1200, first portion is 1200 mm, that you have divided by area is 625 millimeter square, that he also has given 625. Then minus, for the second portion it is minus because it is contraction, compressive force, 320 into 10 power 3 into length is 600 divided by 2500 is the area plus 130 into 10 power 3, that is this value 130 kilonewton into 900 mm length divided by 1250 is the area. Now if you simplify this, you are going to get 0.4914 mm. Please check this. I have given the answer. You please check this. So if you get positive value here, it is elongation. That means finally the stepped bar has elongated. So because of these calculations, we have got positive value. Positive value means it is elongation. Suppose if you get negative value here, it is contraction. Final that stepped bar is subjected to contraction. Now this is the one he has also this delta H. We have found out this. Now he has also stresses in each segment. So each portion, segment means is 1, 2, 3. They are called the segments. Each segment is subjected to different values of stresses. So a simple formula for finding the stress values, you know that stress is nothing but internal resistance divided by the cross sectional area. So sigma 1 is the stress developed in the first portion, which is given by P1 by A1. So P1 is this value, 45 into 10 power 3 divided by A1 is 625 millimeter square. If you simplify that, you will get 72 Newton per mm square. Tensile. So it is because tension force is there, it is tensile stress. Second one is compressive stress. So P2 value we have to take 320 into 10 power 3 divided by area, corresponding area of that segment is 2500. You will get 128 Newton per mm square. Compressive stress. C stands for compressive stress. Sigma 3 once again 130 into 10 power 3 divided by 1250. You will get 104 Newton per mm square. It is tensile. So tensile, compressive, tensile, but the net effect is elongation. So the entire stepped bar it will elongate. So elongation, that means it has elongated like this. When it elongates, the cross sectional area will reduce, but the length will increase. This is the final shape of the stepped bar. So this is what we have to find. So he has asked is a problem of a stepped bar. So this elongation, this side and this side, totally it has elongated by that much value. That is 0.4914 mm. All the elongations or deformations will be very, very small in terms of decimals of millimeters. Okay. So this is what I wanted to explain. Thank you.